Hey, so just because I'm gone doesn't mean that we have to stop learning. So as you can see, we're going to be taking notes today in class. I want you to follow along with the video, follow along with the notes that are in your OneNote notebook, and we should be good to go. Talking about a really important topic for this unit with function notation. This poster, this picture that I borrowed here kind of tells you a lot about what you need to know. Function notation really is just a fancy way of writing y. Once you figure that out, a lot of this stuff actually comes together pretty nicely. Big thing is when you see that f and then the parentheses x, it's not f times x, it's f of x or f at x. But I'm going to try to go as quickly as I can just so I can make sure the video is not too long. At the same time, if you need to pause, rewind, slow it down, I know if I'm talking too fast, that's totally fine to back up the video a little bit and see something again. Make sure we can get it in our notes, and hopefully we're doing a pretty good job of following along with the new information. The one thing that I do have on here is just some quick reminders as far as what a function is and how that all works. Remember, we said a function is a relation in which each x value in the domain is paired with exactly one y value in the range. That's from your notes from last week. Really important to remember that. The idea that one variable would be a function of another, that's kind of like how we say y depends on x. So once I know that x value, I should be able to figure out what the y value is depending on the rule that we have for that function. And that's what we're going to talk about a lot with function notation. But an example that you've even seen in the past is we said something like maybe y equals 2x. Okay, well that means y is whatever double x is. If I double x, I'll have my y. And so then if I said, well, x is 0, well, if x is 0, then y is going to be 0, because if you double 0, you still have 0. If x is 1, then I can put a 1 in, and I'd say, well, y equals 2 times 1, and in that case, that y would be 2. So that's just the basic idea of y depending on x, or one variable being dependent on the other, or a function of another. When we actually talk about function notation in your notes, the main reason we use function notation is more like real-life situations. If I'm going to be dealing with more than one function, sometimes it's helpful to use letters like F or G to name these. F, G, and H are probably the most common ones that you're going to see when we're talking about just basic function notation. Some other ones that you see a lot in the real world is something like D of T. That would be something where we're talking about distance as a function of time. That'd be a pretty popular one. You might also see something with C of, and then a lot of different variables, whether it's time or production or different things like that, where we talk about cost as a function of how many units are produced or what we're doing. But you're going to see some of these things where we name the function. Instead of just saying y equals, we're going to use function notation. So for example, if we were talking about function notation, if I gave you the function y equals x plus 2, the only difference to make it into function notation is you should see, hopefully here, is instead of a y, I now have f of x, and it's important that we can read that correctly, but it's f of x equals x plus 2 instead of y equals x plus 2. Some people say f at x, but that's the main idea, is those parentheses means we're talking about the function at x, or the function of that x value. There gives you a little more information as far as how to read it. That's right in your notes too, but remember, f is not a variable, f is a function, and it's really saying the function at that point, whatever that x value is. So one thing you should really notice, and you can go back to this slide real quick, but we had y equals x plus 2. Now we have f of x equals x plus 2. So hopefully some of you are figuring out the only thing we've really done is we've took out our y and we've replaced it with f of x. So f of x really just stands for y. It's really important that you understand. If I'm talking about f of x in general terms, I'm really talking about the y value that goes with the x value. Instead of an ordered pair x comma y, we have the ordered pair x comma f of x. And then once you figure that out, we can do all the same things that we have done before. It's a shortcut. It's a way to keep track of different functions, and it's also a way to kind of use real-life examples of variables that actually represent what they stand for. Instead of using y and x, we might use distance and time, like we talked about earlier. So first set of examples that I'm going to try to go a little slower on, hopefully, just so you can see how this basically works. Now notice, instead of giving you y equals negative 3x plus 8, I've given you f of x equals negative 3x plus 8. That's the only thing that changed. And so this says, well, find f of x when x equals 5. This is no different than other things that you would have done in the past. When x equals 5, I want to know what f of x is. And so what I'm obviously going to do is I'm going to substitute 5 in for x. And that means I'm going to substitute it in everywhere I see x. Instead of saying f of x equals negative 3x plus 8, now I can say f of 5, or f at 5, equals a negative 3 times 5 plus 8. I've put the 5 in everywhere that I saw an x. Now I just figure it out. Now again, this is not a variable anymore. This is an f times 5. This is just f of 5. This is what your answer is going to be. This is like when you solve for it. F of 5 equals whatever negative 3 times 5 plus 8 is. And I say, well, negative 3 times 5 is negative 15 plus 8. I would end up with a negative 7. My answer is negative 7, or f of 5 equals negative 7. Now this is where you start to see where it's a little bit of a shortcut for us in math. This is not so long. It just says find f of negative 2. Hopefully we can realize instead of saying f of x when x equals negative 2, we just said, hey, look at this. I'm going to put the negative 2 in where there's usually an x. That's going to tell you what to do. Every time you see x, you're now going to put negative 2. So just like we did on the previous example, I can say f of negative 2 equals a negative 3 times negative 2 plus 8. I'm finding the function value or the y value at negative 2. I do the same steps that I did before, and I take negative 3 times negative 2, I get a positive 6 plus 8, and my answer is 14. Some of you guys might just leave it as, okay, hey, my answer is 14. That's totally fine. Others like to write it all out and say, okay, well, f of negative 2 equals 14. And either way works fine for me at this point. I caution you to read this last one closely. This is the one that usually throws people off if they're not doing a very good job of reading. And so I want you to notice when it asks you for something here, it asks you to find x. It doesn't ask you to find f of x, and it doesn't give you f of some number. It says find x when f of x equals negative 22. Might help to remember that we said this f of x is really just standing in for y. So this is kind of like saying find x when y equals negative 22. So just like you would have done in the past, you're going to put this negative 22 in for y, or in this case, you're going to put it in for f of x, and I'm going to find the x value. So when I substitute this, it should look a little different. I'm going to say negative 22 equals a negative 3x plus 8, and now I have to solve for x. The goal when solving equations is to isolate the variable on one side of the equation. We use inverse operations, and whatever we do to one side, we must do to the other. All that stuff is things that we should know at this point, just trying to figure out what x is, and it turns out if I have f of x equal to negative 22, then x must be 10. f of 10 equals negative 22. I'm going to do a couple more examples, a little quicker hopefully, but you'll see one new thing on here. But I'm going to give you a little more example of f of 3. So again, here's where it's nice. You have h of x equals negative 3x minus 3, and f of x equals 2x plus 2. This tells me everything I need to know. It tells me which function I'm dealing with. I'm not going to deal with h. I'm going to deal with the f function. And it also tells me I'm going to put a 3 in for x in that function. So now I can just say f of 3 equals 2 times 3 plus 2. And again, we're just working that out to figure out what f of 3 is. Well, 2 times 3 is 6, plus 2 is 8. And I figured that question out. Notice this one's a little different. It tells you a couple things. First of all, it says, well, find x. So we're back to that idea of not knowing what x is. And then it also says when h of x equals negative 9. So now we're looking back up in this function. We're looking at the h function. It says h of x equals negative 9. Figure out what x is. Well, just like we did on that last example on the page before, I'll put a negative 9 in for h of x, and now I need to solve for x. I have negative 9 equals negative 3x minus 3. Try to get x by itself. Might help you remember the cover-up method too, but I have negative 6 equals a negative 3x, and then I can even divide by negative 3 on both sides, and hey, it looks like x is going to equal 2 in that situation. And then by far the most challenging one that you probably want to star in your notes, make sure that you're paying attention to in this case, would be this last one. This is the first one we've seen like this, but I think it's pretty self-explanatory if you know order of operations and you can read this. In example A on this page, we said that's f of 3. Okay, well when we go down to this first example, we see f of h of 4. And so that tells us what we need to do. We need to find the function f at h of 4. So what I need to figure out first, just like order of operations, I'm going to start at the inside most. I need to figure out what h of 4 is first. So, well, I'm going to come over here and I'm going to say, all right, h of 4. That means on the h function, I'm going to put in a 4. So I would have negative 3 times 4 minus 3. And I got to figure out what h of 4 is. Well, h of 4 is negative 3 times 4, negative 12, minus 3, negative 15. So I figured out what h of 4 is. But I'm not done because I want to know what f of h of 4 is. So in this case, I want to know what f of negative 15 is. I've figured out what h of 4 is, so I can now call that negative 15. So f of negative 15 would equal whatever 2 times a negative 15 plus 2 is. So I have negative 30 plus 2, and I get negative 28. So that's just the very bare bones basics of function notation. If I give you f of x and ask you to find certain things, or I give you more than one equation and ask you to find certain things, that's part of how we're going to use function notation. The other idea to really remember is essentially we're just replacing f of x, or excuse me, we're just replacing y with f of x, and we can do all the same things as before. And so one thing that you're going to notice on the rest of these examples is we're going to go back to a little slope-intercept form. It says write a linear function f of x given that m equals 3 and b equals negative 4. Well, back in the day, we said slope-intercept form was y equals mx plus b. The only thing that's going to change when we're using function notation is now I'm going to say f of x equals mx plus b. And now you should be able to write different functions and different equations based on the information given. Just like we did back in the day, this one's a pretty basic one. It tells me what the slope is, and it tells me what the y-intercept is. It says it's a slope of 3 and a y-intercept of -4. I'm just going to plug those in. I'm going to say f of x equals a -3, or excuse me, I don't know why I wanted to make that negative, equals a 3x minus 4. And I've written that function. I've written f of x based on the information given. The next example that lets you do this is based on a graph. Again, the two pieces of information I'm going to need are m and b. I am going to notice also they want my linear function in this case to be h of x. So now I'm looking for h of x equals mx plus b. Need a y-intercept and we need a slope. Hopefully you can see it on your notes. It's a little blurry, but I can spot that y-intercept where it crosses the y-axis. I can see that b equals -2. The other thing that we need is a slope then. Remember, we always look at slope from left to right. So I'm maybe going to go from the x-intercept to the y-intercept. It looks like I can see some pretty clear spots. It looks like it goes down 2, and it looks like it's going to run 3. And remember, slope is change in y over change in x, so this would be a -2/3. Now I have the information that I need, and I can come over here and say, well, h of x equals, what's m? M is -2/3, so I can put that in for m. Don't forget the x, -2/3 x, and then the y-intercept is -2, so I can say -2. Again, doing the things we did before, just instead of using y, we're using function notation, f of x or h of x or g of x. In this case, it says write a linear function f of x given the table. So again, things that we've done before that you can do. Again, we just need to find m and b. So I'm saying, okay, f of x equals mx plus b. I need the change in y over the change in x, and I need a starting point. One thing that we've talked about quite a bit as far as a y-intercept, remember, whenever x is 0, I'm at that starting point. I'm at that y-intercept. So in that case, when x is 0, we see that y is -7. So that tells me that my b is -7. The other thing that we need to come up with is change in y over change in x. So I want to just kind of look at this table and see, well, what is the change in x each time? And I think hopefully we can see that the change in x in this case is 2. And then we see that the y value is increasing as well, and it looks like it's increasing by 3. So we'd say a change in y is equal to 3. A lot of people would say that the slope is 2/3 then, but remember, it's change in y over change in x. So we actually end up with a 3/2. I now have a slope, I now have a y-intercept, and I can say f of x, remember not y, f of x equals, put in the m, 3/2, and then put in the b, -7. And once again, I've written the equation. One more example of how to do this. You've also done this in old notes. If you look back, I believe it's at Unit 5 when we talked about linear equations and different things. But we can give you the m and the b. We can give you a graph. We can give you a table. And the last thing we can do is we can actually give you ordered pairs. And it maybe doesn't look like we're giving you ordered pairs, but that's exactly what we're doing here. It says write a linear equation, g of x, given that g of 0 equals 9 and g of 3 equals -6. This works back to even what we talked about originally, but notice g of x is now g of 0. That means, they've given me an x value here. Instead of x, we have a 0. That's the first number in the ordered pair. It's 0 something. Then g of 0 equals 9. That's telling me my y value. They've given me an ordered pair here. G of 0 is the same thing as 0, 9. Works the exact same way in the second ordered pair here. I have g of 3 equals -6. That means I have a 3 for my x value, and that makes -6 my essentially my y value, my g of x value. So I have two ordered pairs, 0, 9 and 3, -6. Given this, I should be able to use the slope formula to find the slope between two ordered pairs. Remember, it's y2 minus y1 over x2 minus x1 to find the slope given two ordered pairs. And so that's what I'm going to do. I'm going to say, okay, I have -6 minus 9 over 3 minus 0. Y is on top, x is on bottom, ordered pairs on top of each other. This is old stuff that hopefully we're remembering. I have -6 minus 9. I might add the opposite just to help myself out up there and see that that's a -15 on top. And then 3 minus 0 equals 3, and I have -15 over 3. And I think we could reduce that. -15 divided by 3 ends up being -5 for my slope. So I have my slope. Now I just need that y-intercept. Hopefully we can remember from what we've talked about earlier, whenever x is 0, we're at our y-intercept. So I look up here and I say, hey, that ordered pair helps me out quite a bit. When x is 0, y is 9. That means my b has to be 9. Last step then would be to put it together into an equation. They told me they wanted a function g of x. It was g the whole time, so I'm going to say g of x equals a -5x plus 9. I know it moved pretty quickly. I'm imagining we might have to rewind this a few times. You could definitely flip back through your notes and talk to each other as you work too, but so many examples in here to help you with your assignment today and tomorrow. Writing linear functions given a variety of situations, whether that's a table or a graph or even the very basic of giving slope and y-intercept. And then just don't forget that we also started with the very basics of, if I name you a couple functions, can you figure it out? Maybe have to go back and look at 2c here, f of h of 4. Remember, just start at the inside most parentheses and then you can work it from there. Otherwise, I think just read carefully and follow along through your notes as you work on your assignment, and you should be able to figure most of this stuff out. That's function notation in a nutshell. I hope it goes well for you guys. I hope you work hard, and I hope you're ready to learn some more when I get back.